Hey guys, time for another math problem. This is 8th grade math, Unit 1, Lesson 8, practice problems, rotation patterns. We're looking at rotations, 90-degree rotations, 180-degree rotations, and 270-degree rotations. And what happens to line segments when they are rotated? Let's get started. First, a quick review of the coordinate plane. Please remember that if you're starting from 0, straight up and down is a 90-degree rotation. Then to the side is a 180-degree rotation. And if you go this way, that gives you a 270-degree rotation. Please remember those. We used them in the last assignment and we need to remember that again now. Okay, look at the first problem. Read instructions carefully. It says, for the figure shown here, rotate segment CD 180 degrees around point D. Here's point D. What do you think will happen when you rotate 180 degrees around point D? Well, if it's a line segment and you rotate 180 degrees, then C prime is going to end up way over here. The image is in line with the original line segment. Let me say that again. The image is in line with the original line segment. Okay, let me try it using GeoGebra tools. Click the tool, rotate around point. Click the line segment and then click the point. Type in the angle you want, 180 degrees. Hit OK. Bing! There it is. It is in line with the original figure. Ching! It's as if the line is continuing. I want to label C prime would be over here. Oops. C prime right there. Let's go to the next problem. For the figure shown here, rotate segment CD 180 degrees around point E. Now E is our center of rotation. That is not a point on the line segment. What happens when you rotate around a point that is not on the line segment? Do you remember from the last assignment? If you rotate 180 degrees around a point that is not on the line segment, you get parallel lines. Remember? So D prime will be here, C prime will be here. We're going to get parallel lines. Let's check and see if I'm right. Click the tool, rotate around point. Click the line segment, then click the point, center point E. Type in the degree of your angle, 180 degrees, and hit OK. Bing! There it is. Let me erase my drawing. Now you can see the parallel lines. Let's keep going. Read the instructions carefully. For the figure shown here, rotate segment CD 180 degrees around point M. Point M is the midpoint. What happens when you rotate a line segment around its own midpoint? Do you remember? Well, it just reverses and it lays on top of the original figure. The image is on top of the original figure. C prime will be here and D prime will be here. Now, if I'm right, you won't see any change when I use the GeoGebra tools. If I've done it correctly, you won't see any change. Let me show you. Click the tool, rotate around point, click the line segment, click the point, and then type in 180 degrees. Ding! You can't see any change because the image is lying on top of the original figure. Let me show you another way that could help you imagine this. All right, I'm going to click the rotate tool, click the line segment, and then click the center point. But this time I won't put 180 degrees, I'll put 170 degrees. Well, even better, 150 degrees. There it is. So this is a 150 degree counterclockwise rotation. Let's keep going. Click the tool again, rotate around center, click the line segment, click the midpoint, and then we'll type in 160 degrees. You can see it's getting closer. Right there, that's 160 degrees. If I keep going, it's going to lay down on top of the original figure. So let's do that. Click the tool, click the line segment, click the center point. Now 170 degrees. Bing! Okay, so you can see if I go one more time, 180, it's definitely going to lay down on top of the original figure. Please don't forget, when you rotate a line segment around its midpoint, then the image just lays down on top of the original figure, but opposite direction. Don't forget. Okay, let's have a quick review of what you learned. I'll clear my pencils. In the first example, we rotated around the end point, 180 degrees. What happened? The line segment looks like it just extends. The image is in line with the original figure. In the next example, we rotated around a point not on the line segment. What happened? We got a parallel line segment. These are parallel. That was a 180 degree rotation. Don't forget, that's important. Okay, and then finally, we rotated around the center point. And when you rotate 180 degrees around the center point, the image lays on top of the original figure, but the endpoints are reversed because this is the midpoint. So DM is now over here, DM, and CM is over here. Okay, good job, guys. Let's keep going. The next instruction says, here is an isosceles right triangle. Draw these 3 rotations of triangle ABC together. Number 1, rotate triangle ABC 90 degrees clockwise around point A. I'm going to circle that center point right there. So step 1 was a 90 degree clockwise rotation. Step 2, rotate triangle ABC 180 degrees around point A. Okay, same center point, that's step 2. Step 3, rotate triangle ABC 270 degrees. Right there, I'll just put it here so it's easier for me to remember what I'm doing. Clockwise around A, so that is also clockwise. Why didn't they tell us clockwise or counterclockwise for step 2, 180 degrees? When you rotate 180 degrees, it's just the opposite no matter which way you go. 180 degrees clockwise is equal to 180 degrees counterclockwise. Okay, let's do these rotations, but first, let me try to imagine what it might look like. Number 1 is 90 degree clockwise around center A. Okay, first, I'm just going to move this over here. And I'll erase what I drew and draw that again. So there's my center of rotation. Okay, B is going to go from this line to this line. So that's going to be B prime. I can imagine this. Then this line segment BC is going to go here. So that's going to be C prime, and then my hypotenuse will be there. I think so. Let me try it using the GeoGebra tools. I'm going to click on the Rotate About Point tool and then highlight that figure. Highlight the whole thing and click on the center point of rotation and type in 90 degrees clockwise. Hit OK. Bing! I'm pretty close. Okay, step 2 is a rotation 180 degrees. I'm going to change colors. Okay, 180 degrees. From here, then line BA, well, if you remember, a 180 degree rotation around an endpoint makes a segment in line with the original figure. So that'll be here. And then line CA is also going to be in line with its original figure. BC will be reflected parallel. Remember that this line segment reflected around a point, not on the line segment, gives a parallel line. Okay, that's a lot of marking on my paper, but just hold on. Let's see if I'm right. Click the Rotate tool, highlight the whole figure, and then click the center point. Type in 180 degrees and hit OK. Bing! Okay, so my drawing was a little too big, but I had the lines in the correct positions, almost. Let me erase my pen now. Wait, not yet. Remember step 3 is 270 degrees? So where's that gonna go? Well, 270 degrees clockwise is equal to 90 degrees counterclockwise. So that would be like a 90-degree rotation counterclockwise. What do you know about 90-degree rotations? Let me change my pen color. Oh, red looks good. Okay. If this line segment BA is rotated 90 degrees counterclockwise, then it's going to be here pointing down. And if line segment CB is rotated 90 degrees clockwise, it'll be here. Then I can just draw my hypotenuse. Okay, let me test this, but when I do, I'll put in 270. Then you can see that 270 degrees clockwise is equal to 90 degrees counterclockwise. If you don't believe me, you can try it yourself too. Click on the tool, Rotate About Point, highlight your figure, then click on the center of rotation, and I'll type in 270 degrees clockwise. Hit OK. Bing! I got it. Let me erase all my pen marks so you can see what we got. Let's review. This is a 90-degree rotation around center point A. Here is a 180-degree rotation around center point A. And here is a 270-degree rotation around center point A. Good job, guys. Okay, next one. The graph shows two polygons A, B, C, D, and A prime, B prime, C prime, right here. Describe a sequence of transformations that takes A, B, C, D to A prime, B prime, C prime, D prime. Oh, this is going to be tricky. Well, I think there's going to be more than one way to do it. The first thing I see is if I translate from point A to point A prime, then my polygon would look something like this, right? And then to go from, let me change colors. There we go. To go from this side here to this side here would be a 90-degree rotation around point A. Okay, I got it. Did you see those steps? Let me type it in. Okay, step 1. Step 1 is, uh-oh, my typer just stopped. Hold on. There we go. Okay, step 1 is translation from point A to A prime. Step 2 is a rotation around point A, and that rotation was 90 degrees clockwise. Okay, that's just one idea I can think of. Do you have any other ideas how we could do this? I'm sure there's many more ways, so if you think of one, let me know. Kind of feel like we could have rotated it and then reflected it. What do you think? If we were to rotate this way and then reflect? I'm not sure. I'll stop with that one. Okay, guys, it's your turn. I want you to get on your assignment and try to do it now. See you later. Bye.